Yeah, away we go.
Thank you to everyone for coming along tonight. Today we're having Rob Meaney here, who is the co-author and team guide to software testability and head of testing in Glowfox, Ireland. Rob will be talking to us about how he deals with risks and how he can manage um, and the realities we cannot uh,
Anticipate.
anticipate when it comes to developing our software. Um, Thank you very much, Rob, for coming. And
Cool. Thanks. No bother, man. All right, I'm going to share my screen and bring up my slides, and then I am going to talk at you for probably the guts of 45 minutes. So, can you see my slides now?
yeah,
Yeah.
All right, ready. We're ready to rock and roll. All right, so let's go. So the most profound lessons that I've learned in my career have come from the most painful experiences. Imagine for a moment sitting in front of your development or sitting with your development team at at your company all hands, if you can imagine that, being students anyway, and listening as your CEO tells the entire company that the product that you've been working on for the last 3 years, is a failure. 3 years of blood, sweat, and tears, all for nothing. It's hard to imagine anything more wasteful, more soul destroying than seeing your team pour their heart into building something that ultimately nobody wanted. But this experience isn't unique to us. Research suggests that upwards of 2/3 of all software initiatives either have a negative effect or no effect at all on the key metric they're supposed to impact. This research suggests that optimistically, you and I are spending 2/3 of our time building, testing, and maintaining software that nobody wants or needs. Amazon, by the way, had the highest success rating in the industry, achieving a rating of just 50%. So even the best are still wrong half of the time. So although painful at the time, reflecting on this experience taught me a valuable lesson. Our ability to deliver valuable software was constrained by just two things. Firstly, our ability to manage uncertainty, or in other words, our ability to learn. And secondly, our ability to deal with complexity, or in other words, our ability to adapt our systems safely based on what we had learned. So first and foremost, we failed to learn what the right things to build were. But secondly, to that, we also failed to learn better ways of building the right things. So building the wrong thing better wasn't going to solve our problems. So by the time we had eventually learned what the right things were, what our customers actually needed, we had created an unmanageably complex system that we couldn't safely adapt based on what we had learned. And we found ourselves overwhelmed by technical debt and quality issues. And ultimately, it was this inability to learn and adapt our system safely that killed our product. So in stark contrast to what we had experienced, the most successful companies in the world today have weaponized learning. Their ability to learn faster than the competition is their competitive advantage. Amazon is maybe the best example of this. So Werner Vogel, Amazon's CTO, claimed that Amazon did 50 million deployments in 2014. That's more than one deployment per second. And every single one of those deployments allowed them to learn something about their customers, their systems, or their ways of working. Imagine how quickly they're learning in 2020. So Amazon have had to evolve their practices to manage complexity at a staggering scale over the last 20 years. In order to simply survive, they have had to purposely design their systems to deal with that mind-boggling complexity. They've had to design their systems and ways of work so that individuals and teams can focus on their small part of that huge system. And in the early 2000s, they pioneered ideas like autonomous two-pizza teams, API first service-oriented architecture, distributed decentralized services, infrastructure as a service, and things like ideas like you build it, you run it. And this single-minded focus on, excuse me. This single-minded focus on learning and managing complexity has allowed companies like Amazon, Google, and Netflix to become some of the most successful businesses in the world, achieving speed and safety at huge scale. So, who are the victims when we fail to manage complexity? Why not ask the smug kid in the right in this picture? That's my son, Adam. And for a 24-hour period a couple of years ago, while we were in London visiting Legoland, he was the richest person in our family. Why? Well, Visa had a European-wide service outage. That meant we couldn't withdraw any cash. And so Adam, with a sum total of £45 sterling in his little Velcro wallet, was now our chief holiday financier. And for a moment, I panicked as I tried to figure out how we were going to pay for food, transport, and accommodation in a foreign country without access to our bank accounts. And it was a situation that made me acutely aware of how dependent we've become on our software systems, and how utterly vulnerable and helpless it can make us feel when they don't work. But it also made me think about the teams of engineers that were scrambling in the background to resolve the issue. I've been there myself. I could almost feel the stress, the pressure, and the subsequent shame that they would have to endure. Within minutes of the outage was plastered all over social media, and within hours it was all over mainstream news. I could almost hear the blame-laden questions being asked by senior management. How could this have happened? Why didn't we test for this? So without adequately managing the complexity of our systems, they will fail with horrible consequences. And there are real costs to software failure, financial and human, for both our users and the people building and operating our software systems. So the question is, how can we deliver value to our customers quickly, reliably, and sustainably when we're working in this increasingly complex world where everything is connected, change is continuous, and failure could be catastrophic? Even though Glowfox, where I work, is a relatively small company, we find ourselves working with hugely complex distributed systems, with dozens of interconnected services that are constantly changing and evolving, deployed into a cloud platform, in our case AWS, that we can't rely upon. All cloud providers have outages, and we're integrating against third-party services like Stripe, in our case, whose APIs and responsiveness can change at a moment's notice. In contrast, when I started in the software industry 15 years ago, we had these all-encompassing big bang releases of a monolith. And when it went wrong, it went very, very wrong. And everybody knew. Whereas now we have a constant stream of releases with lots of little failures that may or may not even be noticed. So we have to assume our systems are constantly in a state of partial failure. This scary new world presents a whole new set of challenges and risks, and consequently requires an entirely new approach to deal with these risks. So we need to unlearn our old ideas about development, testing, and operations, and embrace a new reality in this complex world. The truth is, our job is no longer finished when we deploy to production. It's just beginning. This is where we really start to learn about our systems and how they actually behave, as opposed to how we imagine they behave. Tests are not reality. They're simply our best guess. We need to accept that we can't anticipate and test all the ways in which the system could fail. They're infinite. No amount of testing can tell us what will happen in production. We need to shift from imagining how our systems will behave to understanding how they actually behave. So we need to accept that failure is inevitable in these complex distributed systems. And in the face of this reality, we need to rebalance our efforts, not just on prevention and detection of problems, as has been the tradition, but on mitigation and recovery so that our teams can move quickly and safely with justifiable confidence. We need to create resilient, anti-fragile systems. Today's high-performance teams have learned to design testability and operability into their systems from the very start as a means to allow them to manage complexity and the associated risks. So managing risk effectively is the key of delivering value to our customers quickly, reliably, and sustainably. Testability allows us to manage the risks we can imagine, while operability allows us to deal with the realities we cannot. So today I'm going to talk you through the journey that has led me to these conclusions and explore the patterns that cloud native companies like Google and Amazon have learned to adopt over the last 20 years while trying to manage speed and safety at scale. So I'll share the three career-defining experiences and the associated insights related to managing complex systems. The first being testability, the second operability, and the third observability. And these insights have helped our teams not just survive, but thrive in this increasingly complex world. So my journey begins about 6 years ago with testability. And forgive the shameless plug, got the book I co-authored with Ash Winter. I had to get it in there somehow. I had just joined a US hardware company that was building out a brand new software engineering department in Cork in Ireland, which we're all familiar with, I'm assuming. As part of our onboarding, the whole engineering department was asked to perform regression testing for a forthcoming release. So after 7 weeks, yes, 7 weeks of torturous regression testing, the release limped out the door. One of the developers who was acting as the architect in the Cork office, Alex, who also had endured the 7 weeks of torturous regression testing, approached me and asked me how we could design the software to make it easier to test. So we explored the testability challenges we had faced, and I came up with a model I now call the CODS testability model. And CODS is a mnemonic, and the letters are intended to remind us of 4 important testability attributes to consider when we're architecting or designing our software systems. So the first is controllability. And controllability is the ability to identify and control the variables that influence system behavior in order to visit each important state. Next is observability, the ability to observe and understand everything important that's happening in the system. Next is decomposability, the ability to decompose the system into independently testable components. And lastly is simplicity, the ability to easily understand the system. So we implemented our design based on the CODS model, and after overcoming a steep initial learning curve, we began to see truly remarkable results. So let me explore the impact testability had on our productivity a little. So in my experience, a well-tested system is both checked and explored. And that idea comes from a book by Elizabeth Hendrickson called Explore It. So we check to confirm our existing beliefs about our system behavior, the knowns. Does the software do the things we developed it to do? And then we explore to uncover the unexpected risks or the unknowns, the problems we couldn't or didn't anticipate and only become obvious through interacting with the software. And by focusing on testability, we improved both the automatability, which is the ability to automate checks from a coding perspective to confirm expected behavior. It's really great at mitigating risks we can anticipate. And the explorability of the product to uncover the unexpected, the risks we didn't anticipate. So explorability is the ability to quickly, cheaply, and safely learn in an unfamiliar situation by iteratively identifying, testing, and challenging our hypothesis. But that's a bit of a mouthful. So a nicer way maybe to say that would be explorability is the ease with which we can run fast, cheap, safe to fail experiments. So exploration is the most effective means of managing situations of great uncertainty or complexity. It's a very human process centered on learning that requires people to use their intuition, skills, and experience to refine their mental models of a system. The idea of explorability can be applied in a very broad sense, but in this context, by making the software more explorable, it accelerates the speed at which we can gain a deeper understanding of how our systems behave and why. So, as I said, in situations of great uncertainty or complexity, for example, product discovery, when we're trying to figure out which product to build, testing a new feature, or debugging a production issue if a customer is impacted, situational awareness is critical. And that is our understanding of what's going on and what is important. Our best approach to gain situational awareness is to explore using small, fast, safe-to-fail experiments. This process can be modeled by John Boyd's OODA loop. The faster we can iterate through the loop, the faster we can learn and adapt in complex, uncertain situations. So the first step here, as you can see in the model, is observe. Observe is about gathering whatever information you can about the situation. And next we have orientate. This is a very human step. It's about making sense or reasoning about the information. Using mental models, expertise, intuition. It's the most important step. And orientation shapes our observations, decisions, and actions. And then once we've orientated ourselves, we decide, we weigh up our options and we decide what to do. And we act on our decisions. We then observe the results of our action and we iterate through the loop again. And when we do things like exploratory testing, for example, we go through this process. But again, it could be used for all exploratory activities. So going back to my story, before focusing on testability, we were in the bottom left-hand quadrant of this diagram. This is like we had a poor understanding of both expected and unexpected behavior of our software. We spent most of our time either manually checking for expected behavior or fixing flaky test automation. We spent almost no time exploring for unexpected risks, which meant lots of problems were going undetected or were detected very late. By focusing on testability, our automation coverage became far broader, deeper, and more robust, checking thousands of attributes in seconds. It proved excellent at detecting bugs and provided almost immediate feedback on every change. This foundation freed our testers from having to check expected behavior so they could now explore for unknowns or unexpected behavior and risks. We began doing valuable testing that we had never had time to do before. We began to do deep exploratory, performance, resilience, and security testing and finding new and interesting types of bugs. With both great automation and exploration, the speed, depth, and breadth of our testing was incomparable to before. This balance between exploration and automation worked perfectly, as automation failures drove action, provided reliable behavioral change detection. Those failures were invitations to explore, while exploration drove understanding, both of expected and unexpected system behavior. And this combination of fast, reliable automation and deep, skilled exploration allowed us to minimize the time and effort in achieving shippable quality for each new change, or in other words, minimize the transaction cost of getting changes to production. So what did our focus on testability achieve? Well, the design approach was adopted by all of our software development teams in the company. I think there was maybe 6 or 7 teams in Cork, and there was a whole host of teams in the US that adopted it as well. The speed of delivery and quality of the product improved dramatically. It was like light and day. And releases went from 7 weeks of tortious regression testing to a couple of days of exploratory testing by a couple of engineers. But most importantly, the teams themselves were able to work at a sustainable pace and were proud of the work they were doing. And after this experience, I had a profound realization. I realized that significant quality improvements weren't driven by testing. They were driven by building relationships and influencing the right people at the right time to build quality in. So this brings us to the operability leg of my journey. Didn't write this book, but It's in the same collection of books. So I started working with an early stage startup with about 20 people, maybe 6 software engineers, actually here in Cork as well, TrustDev. And we were a business-to-business SaaS-based company providing real-time online fraud detection. And the product was beginning to get traction with some of the biggest retailers in the world. This was a new context for me with a completely new set of challenges. It was the first time I'd worked on a SaaS product, but I quickly learned that because our service was on our customer's cart page, it was critical the platform had to be available, responsive, and scalable to fluctuating customer needs. But building out robust automation and doing deep exploratory testing was only a starting point in this context. This told me almost nothing about the availability, responsiveness, and scalability of the system. I soon found that no matter how much testing I did pre-production, we still experienced problems when we deployed changes. And I realized we were no longer simply testing code, but we were testing complex systems comprised of real users and real data on real infrastructure. We simply couldn't recreate the variety, volume, or complexity of production-type traffic in our test environments. So the reality is, with complex distributed systems, that if you're not testing in production, then your customers are testing in production. So we needed to test where our greatest risk lived, which in our case was in production. And I reframed the CODS model to focus on operability, to make it safe to deploy and test in production. And we did this by, firstly, controlling risk exposure. We began doing blue-green deploys, which allowed us to revert to deployment quickly and easily if we detected an issue with minimal impact on our customers. We started observing system behavior, and we did this by adding instrumentation to visualize our critical customer pain points, things like error rate, and response time. And the whole team monitored the system during our releases. We decomposed our deployments so that each deployment was limited to a single change set, which meant we could quickly isolate the source of a problem if an issue was released. And lastly, we simplified the deployment process. We could deploy a rollback with a single click of a button and created runbooks to help debug issues in production. And this approach hugely accelerated the rate at which we could ship while also reducing the negative impact caused by any issues on our customers. And it really opened my eyes to the power of deliberately testing in production and managing risk with operability. But the single most significant testing challenge that we faced while scaling the company was having to replace our entire persistence layer databases, whatever you want to call them, in time for Black Friday, which is a pretty big online sales day. Again, we applied the CODS operability model when we were designing and planning the change. This time, we decided to control risk exposure using feature toggles. So we added feature toggles to control whether we were writing data to the old persistence layer, the new persistence layer, or both at the same time. And we also added feature toggles to control whether we were reading data from the old persistence layer, the new persistence layer, or both at the same time. To observe system behavior, we added data consistency checks. We added instrumentation so that when we had dual read toggled on, we would read data from the old, excuse me, both the old and the new persistence layer and throw an exception if the data didn't match. This allowed us to do what's called a shadow release. So we deployed the new persistence layer into production straight away behind the feature toggle. We turned on dual write so that the new persistence layer had to silently handle real production traffic volumes. And we monitored its performance and addressed the issues we found without any customer impact. Then we turned on dual read with verification. Again, we identified and fixed any data integrity issues using real production data without customer impact. A matter of weeks later, we turned on the new persistence layer before Black Friday with no issues, and the company was sold a matter of months later for 44 million euro, I think, of which I got very, 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 very little. This again showed how a focus on operability can turn a hugely risky, complex change into a routine, controlled, stress-free affair. So here are some examples of the techniques I've used when designing for operability. Again, using CODs to manage risk. There are more than this, but this is just a handful. So in order to control risk exposure or controllability aspect, we can use blue-green deploys, feature toggles, canary releases, A/B testing. From an observability perspective, we can use things like logging, monitoring, tracing, alerts, and synthetic tests. Decomposability, as I said, breaking our deployments down into a single change set. And from a simplicity perspective, things like a single click of a button to deploy or rollback, automatic rollback on error rate spikes, and things like that. So another lesson I've learned is that when it comes to operability, you have to go beyond just testing the production code. You need to test the infrastructure and tooling that supports operability. It's essential. Excuse me. It's essential to resilience test your operability infrastructure. You need to test that your infrastructure and tooling work when you most need them, which is when things go wrong, right? Because inevitably things will go wrong. So you need to be able to recover gracefully when they do. So this brings me on to the observability leg of the journey, and we're getting close. We're getting close to the end. So my last role was quality engineering manager with Populo, based here in Cork. I worked with all of our engineering teams, enabling them to identify and achieve their quality goals. Now, having seen the power of designing systems with a focus on testability and operability, I shifted my focus from testing to coaching teams to build quality into the product from the start. As a coach, one pattern I've identified is that of the 4 CODS operability attributes, observability is the first and most important thing that teams need to focus on when I begin working with them. Why? Because observability allows the team to get a true understanding of how healthy their system currently is, of how their system actually behaves as opposed to how they imagine it behaves. It allows them to understand the reality that their users are experiencing. And lastly, it allows them to identify where they need to focus their quality efforts. But observability starts with some very simple questions. So how would you know if your system was unhealthy? How would you know if your users were having a bad experience? In the event there was a problem, how would you isolate the cause? So we want to give our systems a voice or a way of saying, I'm healthy or I'm unhealthy. So this simple technique of asking the questions as I just went through gets teams thinking about what aspects or attributes of their system are really important. It gets them identifying and adding important health indicators using things like service level objectives. It gets them gaining an understanding of what normal system behavior looks like so that they can identify abnormal system behavior. So once we have the fundamentals in place, we can extend these ideas across the business to understand the relationship between the various layers that I've shown here in this pyramid, I guess it is. At the base, we have infrastructure, and we can monitor things like utilization, saturation, and error rate. And next, we have the services that sit on top of the infrastructure. And we can monitor things like request rate, error rate, and request duration. And then we can progress to custom SLO, our service level objectives. Next, on top of the services, we have the product as a whole, and we can monitor things like successful user tasks completed. And on top, so once our users can successfully complete their tasks, we can start monitoring our users, our customers' success metrics. So how successful our product is making our users. And lastly, we can start monitoring how successful our business is based on business metrics or KPIs. So you can see here that we have observability throughout the stack. So this may seem familiar, but I believe a well-observed system is both checked and explored. So we check the system for known failure scenarios, the knowns. Symptoms we know are indicative of customer pain. And we explore the system for unexpected behavior or unknowns. We explore the data looking for unusual patterns. We check for symptoms or indicators of customer pain. And there are a finite number of indicators of pain. And in the case our customers are experiencing pain, we explore to identify the cause or the source of that pain. For example, when we go to the doctor, we don't list all the possible causes of our illness, we list our symptoms. So by focusing on observability, we improved both the monitorability, which is our ability to detect customer pain, and explorability, which is our ability to understand system behavior or the cause of pain of our production systems. So previously in Populo, we had low observability. So we wasted most of our time in a sea of noisy, unreliable alerts and created hundreds of dashboards for every potential cause we could think of. But more often than not, it was our customers that were reporting the issues, not the alerts. And even when they did alert for genuine system outages, they only told us we had a problem. And it was very difficult to isolate the cause of the issue. The results of focusing on observability were that teams had a smaller set of better, more reliable alerts that were focused on identifying the symptoms of customer pain, not monitoring for cause. And when they alerted, we knew we needed to act immediately. The explorability allowed the teams to get a deeper understanding of system behavior and quickly slice and dice the data to get to the cause when there were outages. We could ask questions of the system without needing a release. These teams are now curiously exploring their production data, some as part of their daily stand-up, and even finding legacy bugs by identifying unusual patterns in the data, bugs that otherwise would never have been found. In many cases, these teams were now able to quickly detect system outages and correct problems before customers were even impacted or aware of the issue. So great monitoring drove action, allowing us to quickly detect production issues, while great explorability allowed us to understand the cause of the problem through skill debugging. And it's this combination of this combination minimized the effort in detecting and resolving production issues. So having seen how effective observability was with our software systems, I decided to try build observability into our systems of work so that we could understand how we were performing as an engineering organization. So we adopted the Accelerate metrics from this book called Accelerate by Nicole Forsgren. If you haven't read it, I suggest you do. It will be very good for your career. And so I adopted the Accelerate metrics from the book to help guide us at a team and department level in our quest to deliver value to our customers quickly, reliably, and sustainably, because these indicators are scientifically proven indicators of high performance delivery teams. So there are 4 key metrics. The throughput metrics consist of deployment lead time and deployment frequency, while the stability metrics consist of change failure rate and time to recover. So what I noticed when I did this was an interesting relationship between the Accelerate metrics and how testable and operable our systems were. Teams with low testability and operability were low performers. Their testing was slow and ineffective, and when they had production issues, the impact was huge on the team, the business, and our customers. By improving testability, teams made more informed decisions on the risks they could imagine or anticipate, reducing the likelihood of introducing a failure, allowing them to move more quickly with confidence. While by improving operability, it allowed teams to deal with the realities they didn't anticipate. Remember, failure is inevitable, so it allowed them to reduce the impact of failure when it inevitably did occur. And the combination of high testability and operability provided a hugely powerful mechanism for managing complexity and the associated risk. So testability reduces the likelihood of failure, while operability reduces the impact of failure when it occurs. And this allowed our teams to produce quality at breakneck speeds. So focusing on testability drove throughput in terms of the Accelerate metrics. It reduced the lead time per change, and it increased deployment frequency. which ultimately minimize the time and effort to ship changes to production. Operability drove stability in production in terms of reducing our change failure rate and our mean time to recover, which ultimately minimized the time and effort our team spent dealing with quality problems in production. So these combined allowed us to achieve optimized flow by accelerating delivery of value and minimizing the cost of poor quality. So although it may seem like it makes sense to always invest heavily in testability and operability, I've learned that in some circumstances, it's not necessarily the best investment. Our deployment decisions have consequences ranging from a crappy experience for our users, to loss of money for either our business or our users, or in very unfortunate circumstances, maybe even loss of life. So understanding that context and the potential consequences of failure is critical. We need to ask, what do we have to lose here? And tailor our approach appropriately. For high impact, irreversible decisions, rigor is paramount. We need to invest heavily in both testability and operability to prevent failure and minimize impact. While for decisions that are low impact and reversible, we want to optimize for speed, allowing our team to iterate quickly so we can out-innovate the competition. So in Populo, for example, our lean approach to product development meant that sometimes teams were working on new experimental features and other times on enhancements to business critical features. But the teams were applying the same engineering rigor in both situations, meaning that we were investing huge amounts of time and effort in potentially throwaway experiments. What I realized was that we needed a different approach depending on whether we were building to learn or building to earn. So the 3X model from Kent Beck, which I've shown here, and helps guide our investments by understanding which phase we're in. When we're building to learn, there's lots of uncertainty, but also a huge amount of opportunity. We want to do lots of small, fast, cheap experiments, and we want to optimize for opportunity costs, because as we know, 2/3 of ideas are wrong. In the explore phase, the more experiments we can do, the more we learn, and the more likely we are to find a winner. We invest as little as possible to test the basic functionality and to observe and control the experiment in production. Most ideas are bad. They will fail, and we'll end up removing them anyway. On the rare occasion one of our experiments resonates and we achieve what's called product market fit, which is when the market says, yeah, I really want this, right? So the market's in control of that. We enter the expand phase. We do everything we can as an engineering organization to scale to market demand and increase our investment in testability and operability. But only when there's evidence that the software is valuable. Okay, so it's only when we achieve product market fit and we see that users are deriving value from this that we invest in testability and operability. In ways, managing complexity doesn't actually matter until somebody cares. So once we've overcome our scaling challenges, we move into the extract phase. We begin to focus on return on investment and efficiency. Our customers now depend on this functionality. Therefore, we must invest heavily in designing our systems to manage complexity. We need to be able to adapt our system safely. Any issues or downtime are very costly. So we invest heavily in both testability and operability. So having talked through each of the significant experiences that have shaped my perspectives in software delivery, there's a clear pattern emerging. As I said at the very start, the most profound lessons I've learned in my career have come from the most painful experiences. So as Ray Dalio says, pain plus reflection equals progress. So when you experience pain, take time to reflect and try to take lessons from the experience. Being part of a failed project taught me to take an experimental, evidence-based approach to learning. Experiencing the pain of working on unmanageably complex products, that were painful to test and operate led me to discovering the value of managing risk by designing systems with testability and operability in mind. So to come back to the title of my talk, if testing is not the goal, then what is? So software systems are socio-technical systems. They are created by people like you for people, okay? So we develop these things for people. So the goal is to deliver software that improves people's lives. We want to build things that matter, things that change the world for the better. But we also want to minimize the suffering caused when things go wrong. But we can't do that on our own. We can't focus on development in isolation. We can't focus on testing in isolation. We can't focus on operations in isolation or support in isolation. The huge leaps in productivity that I've spoken about related to testability and operability can only occur when developers, testers, ops, and so on work together. I've even begun to see huge benefits to working closely with our customer support team in my current role. The whole team is the unit of delivery. Therefore, we must optimize for the whole, not the parts. Our team includes everyone involved in taking an idea from concept to customer. So in order to deliver value to our customers quickly, reliably, and sustainably, we need to cultivate an environment in which an amazing delivery team experience will emerge. A team experience focus on using learning as a weapon. So continuously learning through safe to fail experiments focused on unearthing the right things to build and better ways to build the right things together. Focused on investing based on evidence. So most ideas will fail. So we only invest heavily once there's evidence that this change is valuable. Otherwise it's removed. And using pain to drive better design. Continuously evolving the design of our systems to address the biggest pain points bubbled up by the delivery team. So the most effective way I've found of doing this is by visualizing, socializing, and optimizing for the whole team experience. So we want to create safe spaces, psychologically safe spaces, where everyone involved in building, testing, deploying, operating the software is encouraged to share their experiences openly and honestly. Using events like incident reviews, team retrospectives to genuinely learn about our systems. Where managers, developers, testers, UX, product, operations support are empowered to visualize the challenges we face as a team. To socialize the impact of those problems, both on individuals and the team as a whole. And then, most importantly, to give the team time and space to work together to overcome their biggest challenges. Because if there's one thing that I've learned in the last 6 years of working in this complex new world, it's that when you optimize for a great whole team experience, you get happy, high-performing teams as a second-order effect. Because I believe that life is too short to build software that doesn't matter. Life's too short to have complex systems that fail horribly and inflict pain and suffering on our teams and users. So let's build organizations and teams obsessed with learning. To quote Peter Senge, the only sustainable competitive advantage is an organization's ability to learn faster than the competition. And we also want to design our systems together so that they can be safely adapted based on what we learn. So that we can be part of happy, productive teams working in successful, innovative businesses, delivering valuable software to satisfied customers. My name is Robert Meaney. Thank you very much.
Thank you very much.
No bother.
I guess we'll take questions now. Do you want to stop the recording, Omar?
Yeah, I will do now.